Barbara is investigating the relationship between the average income and average annual carbon dioxide emissions for different countries. She takes a random sample of 24 countries and finds the product moment correlation coefficient is going to be 0.446. Stating a hypothesis clearly, test at the 5% level of significance whether or not the product moment correlation coefficient for all countries is greater than 0. So is there enough evidence from this sample that there is correlation, either positive correlation in the whole population? So let's set up our hypotheses. H naught is going to be that there isn't correlation, and H1 is that there's going to be positive correlation. And now we just need to look up the critical value in the table. We don't need to do any calculations. So here we go. We are doing a 5% significance level. N is 24. So we're going to look along this row and down this column. That's our critical value for whether there's correlation or not. And it's positive, so we're going to take the positive 0.3438. Sorry, why am I putting it over there? Over here, 0.3438. And our actual value here is going to be to the right of it. So remember, any value above the critical value is going to mean that we reject H naught, and we can see we're in the critical region. So reject H naught. There is sufficient evidence at the 5% level that the population has positive correlation. Now, Barbara believes that a non-linear model would be a better fit for the data, and she codes the data as shown and obtains this model here. So we're getting into the idea of logs here, how you can have a non-linear graph and you can actually log one or both of the variables. In this case, it's both. And if you get a straight line, then you know it's a very particular kind of curve. In fact, it's going to be this sort of curve. And because the product moment correlation coefficient is very close to 1, it means that a straight line will be a good fit. So that's why the value supports Barbara's belief. Are approximately 1, which implies a straight line will be a very good fit. I will circle back to this at the end. We're asked to show that the relationship between y and x can be written in this form where a and n are constants to be found. So the way to go about this is, rather than going from here and trying to get to here, let's do the opposite. Let's take logs of both sides. This is something to practice many times. I'm just going to write log instead of log to base 10, but it's implied. So log y is going to equal log a x to the n. I'm going to show all my work in here, be really careful. I can write that as log a plus log x to the n, separating it, which is then, I can bring the n down, and I'm going to write it as n log x plus log a. And this is what I was talking about before. So if you have this curve and you were to plot it, I mean, I can't say exactly what it would look like at the moment because it depends on the value of n. But for example, if n was 2, we'd actually get a kind of a quadratic going on. But if you actually, instead of plotting y against x, you plot log y against log x, then you would get a straight line, something like this. And so the converse is true. If you get a really good straight line, then it means that actually the nonlinear fit was good originally. which is what part B was talking about. I said I would circle back to it, so that is me doing so. So at this point, what I can do is compare this with this. Remember, they've told us they've coded it. So log y was C and log x was M. So I can see well, they've actually written it. I wouldn't write it like that. I prefer to write it as in the form mx plus c. I really don't like the fact that you used m either personally, because m's always used for the gradient. Anyway, so what we have is that n is going to be 0.89. That is the gradient of our curve here and here. And then log a is going to equal minus 1.82. So to get a, we can do 10 to the power of minus 1.82, and this gives 0.01513. So that means I can write down that y is equal to 0.0151 multiplied by x to the power of 0.89. That would be a curve that would fit the data, not perfectly, because r is not 1, it's just very close to 1, but it would be a very good fit, and we could maybe make some predictions based on that. And we're done. Well done.